this video, we're going to take a look at the distance formula. So remember the distance formula between 2 points, x1, y1, x2, y2, is going to be the square root of the difference in those x values. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And it doesn't matter which one we call point 1 or which one we call point 2, as long as we're going to subtract the two x values, find that distance, square it, find the difference in the y value, square it, and then take the square root of the sum. All right, so for our first example, we're looking for the distance between the points 1, -2 and 3, 2. So our distance is going to be the difference in those x values. So 3 minus 1 is going to be the distance in our x values. X values is always listed first. Plus our y values are 2 minus a -2. And those are going to always be the numbers listed second in that ordered pair. All right, so if we simplify this, 3 minus 1 is 2. 2 squared is going to give us 4 for that first term. 2 minus a -2 is going to be 2 plus 2, which is 4. And so we get plus 16 when we square that. And that's going to add to give us 20. We can reduce 20. Square root of 20 is the square root of 4, which is 2 times the square root of 5. So the distance between those 2 points is going to be 2 times the square root of 5. All right, if we wanted to find the distance between the point K, R, so K is our x value, R is our y value, and the origin, we're going to do the exact same thing. So we get 0 minus K quantity squared plus 0 minus R quantity squared underneath that square root. And 0 minus K is going to be a -K squared. Negative times a negative is going to give us a positive, so that's going to simplify to K squared. And then 0 minus R is going to be -R squared, and again, a negative squared is going to give us a positive. And without knowing what K and R are, we can only simplify it that far to the square root of K squared plus R squared. All right, now let's look at an application of the distance formula. Here we're going to plot the points and form the triangle ABC. We are going to verify that that triangle is a right triangle and find its area. All right, so the point A is -1, 5. So -1, 5 is going to be in quadrant 2. B is the point 0, 2, so that's going to be on the positive x-axis. And then C is the point 3, 1. It's going to be in quadrant 1. So we get a triangle. And not completely sure which one's the right angle. I'm thinking it's probably going to be this angle at C, but we can check that because we know that the sides in a right triangle, we have a squared plus b squared equals c squared. And where A and B are going to be the two sides, the lengths of the two sides that make up that right angle, and C is going to be the side across from that right angle. So we'll see if this is the correct setup. If not, it almost looks like it could be either that angle at B or at C, but I'm thinking it's probably C based on my drawing. All right, so the distance between A and C, let's go ahead and find the length of that side. So that's going to be A and C. So our difference in our x values is going to be 3 minus a -1 squared plus 1 minus 5 squared. And I'm going to go ahead and leave, since we're going to square these, I'm going to leave these underneath the square root and not simplify them past that. So we get 3 minus a -1 is going to be 4 squared is 16. And 1 minus 5 is -4 squared, which is also 16. And so we get the square root of 32. And I'm going to leave it like that. I'm not going to simplify that square root because I'm going to go ahead and plug it in and square it anyway. So I've got that this is the square root of 32. Let's go ahead and find the distance between A and B. And this will tell us right now whether we pick the right one that could potentially be the hypotenuse, because remember the hypotenuse is always going to be the longest leg in a right triangle. All right, so the difference between A and B now, we've got 2 minus a negative 1 squared plus 0 minus 5 squared. So 2 minus a negative is going to be 2 plus 1, or 3 squared, which gives us 9 for our first term. And then negative 5 squared is 25. When we add those, we get that that's going to be 34. So we did actually have them switched as far as which one's our hypotenuse. So it's not going to be that right angle. It's going to be, this one's going to be our right angle, because that side, wait a minute, no, I was right. Sorry. That is going to be our right angle, because the side across from it is going to be our longest side. All right, now let's find the length of that third side. So B to C is going to have a distance of 3 minus 2 squared plus 1 minus 0 squared. 3 minus 2 is 1 squared. Sorry, my dog's joining us. 3 minus 2 squared is going to be 1, plus 1 minus 0 squared is also 1, so we get square root of 2 is that little side there at the end. And we do see that if we plug in A and B, or the two shorter sides, so the square root of 32 squared plus the square root of 2 squared is equal to the square root of 34 squared, because that's going to give us square root of 32 squared is 32, the square root of 2 squared is 2, and the square root of 34 squared is 34. That is a true statement, so that means ABC is a right triangle. Now let's find the area. Remember, the area of a triangle is 1/2 base times height, and our base here could be either of the two sides that make up our right triangle, and our height is the other one. So we get 1/2 times the square root of 2 times the square root of 32. So 1/2 times the square root of 64, 2 times 32, what's under the square root, we can multiply with what's under the square root, and the square root of 64 is 8. So we get 1/2 times 8, or 4, we don't know what the units are on this, so it's going to be whatever those units are squared. All right, I'll see you guys next time.